Okay, so in the last video we were almost finished question number 3 on page, what was that, 536. So we had found the VFX. We were just about to find the VFY. When you do it, you get 39.245 meters per second. So you have 22.4 meters per second here. 39.245 meters per second here, and so you find your VF and you find this theta. So square them, add them together, take the square root, and get 45.1877 meters per second. And you find this angle because this one and the one with the ground are the same, alternate interior. So you always find this top one. And so and when you do, you should get 60.23283 degrees. And then WRT is with respect to ground. Okay? And that's the end of 3. All right, I also asked you to do 4. In 4 it says an archer shoots an arrow towards a target, giving it a horizontal velocity of 70.1 meters per second. So VIX, and he's shooting it at a target over here, and of course it doesn't go in a straight line past. So this is the spot he's aiming for, and this is how far below. It's delta dy you're looking for. So VIX is 70.1 meters per second. VIY is 0. AY, of course, is 9.81 meters per second squared. And AX is 0. And then it says the target is 12.5 meters away. So delta dx is 12.5 meters. Now, sometimes the way it's worded, people don't understand the diagram. Okay, so it goes down a vertical distance, and that's what you're looking for, delta dy. And of course we don't know the time for either of them, but we know it's the same. So this time your one unknown is in the x direction, so you're going to start there. Delta dx is equal to VIX delta t, 1/2 ax delta t squared. This term goes to 0, solving for time, delta dx over VIX. So 12.5 meters divided by 70.1 meters per second will give you a time of 0.1783 seconds. Okay, so then once you have that time, now go to your y. So delta dy is equal to VIY delta t plus 1/2 ay delta t squared. The VIY is 0, so this disappears. And this time you're solving for delta dy. So 1/2, 9.81 meters per second squared, times the time you just found, 0.1783 seconds. Remember to square it. Delta dy ends up being 0.15596 meters. So 15.5 centimeters below where he was wanting to hit it. All right, I skipped 5, 6, and 7. I didn't assign them, not because you couldn't do them, but just because really they're identical. So if you want more practice, or if you didn't do 1, 2, 3, and 4, try 5, 6, and 7 because they're really exactly the same. And so it's always good to do a few on your own without me. So give them a shot, and if you want to know the answers, drop me a note and I'll let you know what they are. Number 8's a little bit different, so that's why I assigned it. So number 8 is a bullet that's being fired from a gun, given a horizontal velocity, and then of course eventually hitting the ground. And at the instant the bullet is being fired, the shell case is also falling. I can't get this arranged so I can see the book. And so this will be the cases given, and then this will be the VIX, the X for the bullet and the Y for the bullet. So the VIY, of course, is 0. and the AY is 9.81 meters per second squared. And it tells us that the VIX is 300 meters per second. And for the case, the VIY for the case is 0. And the AY is 9.81 meters per second squared. And it tells us that the case hits the ground with a speed of 5 meters per second. Okay, so both of these, of course, are down. And this is down. And so then it says, how far does the bullet travel? So AX, of course, is 0. And you're looking for delta dx. But to find delta dx, you're going to need the time. So we don't have the time here. We also don't know the delta dy. The casing is the key. So if you take a look at the casing, it's falling from exactly the same height as the bullet is at, and it hits the ground at going 5 meters per second. So shouldn't it take the casing the same amount of time as to hit the ground as it does the bullet? Because we don't know the delta dy's, but whatever they are, they're the same. So we could find it, but we really don't need to. What we need is the time. And if we know the delta dy's are the same, then the times have to be the same. And so why don't we just find the time by doing VFY minus VIY over delta t? So delta t is equal to VFY minus VIY over AY, and the VI is 0. So 5 meters per second over 9.81 meters per second squared. Delta t is equal to, then, when we do this, 0.50968 seconds. This is the time it takes the casing to hit the ground, but it's also going to be the time it takes the bullet to hit the ground, because they're falling from the same height. Now, people always say, no, that can't be true, because you think you're throwing a bullet out. Yeah, so but the time it hits the ground has nothing to do with how fast it's going out and everything to do with how high above the ground it is. And so whether you drop something or you fire it straight out, it's going to hit the ground at the same time. And if we were in class, I would hold 2 books in my hand, and one I would drop and one I would fire horizontally, and you would hear them hit the ground with a single thud. What messes people up is you see how far this one has traveled. But remember, that's the x direction. So the time that it takes to hit the ground is determined by the y. And then that time is what then allows it to travel outward. Okay, so once you get the time, then you just go delta dx is equal to VIX delta t, 1/2 AX delta t squared. This goes to 0. Delta dx is equal to 300 meters per second times 0.50968 seconds. When you multiply this, you get 152.9052 meters. Okay? So the only thing that firing it outward does is change the distance it's traveled in the x direction. So if I drop something, and from exactly the same height I fire something, they're both going to hit the ground at the same time. It's harder to see with a bullet because usually a bullet hits something else before it hits the ground. But if we had an uninterrupted range where the bullet could actually fall to the ground, it would reach the ground at exactly the same time as the casing. Isn't that crazy? All right, now hopefully horizontal projectiles are pretty good. I will assign a few more for you tonight just to make sure, but it's time to move to angled. Okay, coming soon.